Okay, the first problem I have here is cosine theta equals 3 over 5, comma, open parenthesis, 270 degrees, comma, 360 degrees, close parenthesis.
Okay, and what's the question?
Find the values of sine 2 theta, cosine 2 theta, and tan 2 theta for the given value and interval.
Sine 2 theta, cosine 2 theta, and what's the third one? Tan?
Tangent 2 theta.
Okay.
Yes.
All right. Let's talk about what's the general formula for sine of 2 theta.
Wouldn't it be, 1 second, 2 cosine x and cosine x plus 2 cosine x?
No, it's real simple.
0.
Just 2 sine theta, cosine theta.
2 sine theta, 2 cosine theta.
Okay. Now, we know what the cosine theta is. It's 3/5. What's the sine theta? How do I figure out what the sine theta is, given that they've told me what the cosine theta is and they've told me what quadrant?
Make a triangle.
Yes. Good answer. Always make a triangle and label theta. It's important you do both. Make a right triangle and label theta. Now dimension everything you know about that triangle. What's the adjacent side to theta equal?
3.
What's the hypotenuse equal?
5.
Now figure out what the opposite side is equal.
It's a 4. It's a 3, 4, 5 triangle.
Now what's sine theta equal?
So that would be 4 over 5.
What's its plus or minus sign in the fourth quadrant?
Plus or minus sign? I have no idea.
Okay. When you have a unit circle, easiest way to remember this is remember you number your quadrants counterclockwise.
Okay.
All students take calculus. What that means is that all 6 trig functions are positive in the first quadrant. In the second quadrant, only sine and its reciprocal is positive. In the third quadrant, only tangent and its reciprocal is positive. And in the fourth quadrant, only cosine and its reciprocal is positive. Since we're in the fourth quadrant, sine has to be what?
Negative.
Right. Okay. So now we know what the cosine is, we know what the sine is, we can answer that question. What is it? 2 times, what's sine theta?
Negative 4 over 5.
And what's cosine theta?
3 over 5.
Multiply that out, and you have minus 24/25 is what the sine of 2 theta is.
Okay.
And notice that we never once figured out what theta was.
True.
No need to. That's the beauty of trig, is that you might think that, well, I can take the inverse cosine of this and come up with this angle, and then I can multiply that angle by 2 and just figure out what the sine of that thing is. And you could do it like that, but they don't want you to do it like that. They want you to do it using the double angle formula.
Okay.
Okay, now, what did we say the sine of theta was? We said the sine of theta was minus 4/5.
Yes.
So let's talk about the cosine of 2 theta that they want to know. What's
That would be 2 cosine theta times sine theta.
No, there's actually 3 identities for cosine of 2 theta.
Okay.
And it's hard to explain why there's 3, but at some point in trig you'll get why there's 3. The first one has both sine and cosine in it. It's that one. The second identity has only cosine. It's that one. And the third identity has only sine. Notice kind of the similarities between these two. Okay? So, in order to figure out what cosine of 2 theta is, I merely need to know what the cosine of theta is, or the sine of theta, or both. Which one would you use? In other words, we've already done this because we went to all the trouble of figuring it out, but let's say we hadn't figured out what sine of theta was. Then we could use this identity here because we know what the cosine of theta is.
Mm-hmm.
So let's use that one.
Okay.
We don't have to do any more work. So what's 2 cosine squared of theta minus 1?
Would I add 1?
It's minus 1.
Okay.
Notice one way to remember these a little bit easier is that it's subtraction in all 3 identities. This is subtraction, that's subtraction, that's subtraction. At no point are you adding anything.
Okay.
Okay? So it's 2 times cosine squared of theta. What's cosine squared of theta going to be?
3 over 5.
Squared.
9 over 25.
Minus 1. There's your answer. In other words, 18.
Oh, that's it?
Well, I got to simplify it. That's equal to minus 7 over 25. You see how you know how I did that?
Yes. Numerator.
Yeah, I just found a common denominator. In other words, that's 25 over 25. And then 18 minus 25 is minus 7. So that's what the cosine of 2 theta is. Now, there is kind of one advantage in knowing what theta is it gives us a way to kind of check things. Okay, well, most people don't know this because it's just kind of an odd thing. But when you have a 3, 4, 5 triangle, which is what we're dealing with here, everybody knows a 3, 4, 5 triangle, but not very many people know what the angles are because it just never comes up. Okay, well, it turns out that that's 37 rounded off, and that's 53 degrees rounded off.
Okay.
So theta must be this angle here, right? For the cosine of theta to be 3 over 5, theta must be that 53 degree angle.
Correct.
So the cosine of 2 theta would be the cosine of 106 degrees, puts it in the second quadrant, better be negative. And in fact, we came out with negative. Had we come out with positive, we'd have known we made a mistake.
So then you can check it. Okay.
Yeah, so it's always a good idea to have some way of checking. And without knowing theta, it's hard to know what quadrant 2 theta is in. Not that we need it. In other words, I didn't absolutely have to know it was the second quadrant, as all I had to know was these 3 identities and pick the easiest one. Notice that if I know that the sine of theta is minus 4/5, I could use this one here. I'm going to get the same answer.
Yeah.
Or, since I know both cosine and sine, I could use this one here. I'm going to get the same answer. But the reason, and it's kind of strange, but only the cosine of 2 theta has 3 different identities. In other words, why it and not sine of 2 theta is something I've always wondered. And then finally, the tangent of 2 theta, the identity for that is 2 tan theta divided by 1 minus tan squared theta. Well, I guess we need to figure out tan theta. Here's our triangle again. There's theta. What's the
Opposite of adjacent.
so
So it would be 4/3.
so tan theta is 4/3, but in the fourth quadrant, what is it?
It will be negative.
So it's actually negative 4/3. And yeah.
And I have a quick question. How can you actually, so you determine what quadrant it is in
Well,
based on the
I'm assuming that when they said 270 to 360, that
Okay.
that meant fourth quadrant. Now, that's not usually the way it's expressed. The way it's usually expressed is the following. Theta
Radian.
is greater than or equal to 270 and less than 360. That's the way the domain is usually expressed when they're limiting or when they're trying to tell you which quadrant it's in.
Okay.
Okay? So we know the tangent of theta is 4/3. It's in the fourth quadrant, so it's minus 4/3. So let's plug it in. 2 times minus 4/3 all over 1 minus. Now the minus 4/3 is going to become positive.
It's squared.
Right. So tangent squared of theta is 16/9 positive.
Yes.
Okay, so now we have minus 8/6 in the numerator divided by minus 7/9 in the denominator. See where I got those numbers?
Yes, you filled in the 9 since it's only.
Now how do I divide fractions?
You do reciprocal.
And multiply, so I've got 8/6 times 9/7. Negatives are going to both cancel, so whatever that number is, 72 over 42.
Yeah, 42.
And you can at least simplify it. You can cut each one in half. So that's 36 over 21. Now I see I can divide that by 3 and that by 3. So 12.
12/7.
That's your answer.
Okay, so I'll leave it as an improper, right?
I prefer improper rather than one, mainly because trigonometry is all about ratios. Okay?
Okay.
Well, if I tell you I have 1 and 5/7, I don't really have a ratio. But if I tell you I have 12/7, I'm ready for trig. Trig is all about ratios. So I would leave everything in improper fractions. Simplify them for sure, but don't turn them into proper fractions.
Now I get it.
Okay.
It's not that bad, but it just takes a lot of time.
Well, mainly you just have to memorize a lot. Trig is more memory than any other math you've ever had.
I noticed.
And I don't know whether your teacher allows you to take a cheat sheet, what they call, where you can take all your identities in on a card when you take the test.
Nope, she doesn't do that at all.
Okay, so you got to memorize. That's the only other solution. All right, what other problem do you have here? Let's see. You did 2 half-hour sessions? You meant to do that?
Yes, an hour. Yep.
Okay.
And I have this next one. Okay, you ready? Okay. tan theta equals 8 over 15, comma, open parenthesis, 180 degrees, comma, 270 degrees, close parenthesis.
That's interesting notation. I have not seen that before.
Yeah, it's in the math book.
Yeah, no,
That sheet.
I mean, I understand what it means, but usually there's a theta in here with greater than or less than to let you know what quadrant we're in. But this lets you know. In other words, this is kind of condensed notation. I actually prefer this. It's simpler to write.
So that means we're in the third quadrant?
Correct.
Okay.
Okay, so first thing, and they want to know the same thing, what the sine, cosine, and tangent of 2 theta are?
Correct.
Okay, so we know that to get the sine of 2 theta, we need to know what the sine of theta and the cosine of theta is.
Yes.
So let's do this step. Let's figure out all.
The opposite is 8, then the adjacent is 15, and then 64 plus 15 squared.
One of those special Pythagorean triangles.
Oh, it's 17.
8,
okay.
15, 17, yeah. Okay, so let's figure out what the sine of theta, the cosine of theta, and the tangent of theta. Well, we know what the tangent of theta is. They gave us that, 8 15. What's the sine of theta and the cosine of theta?
The cosine is 15 over 17.
What's its plus or minus sign?
So ASTC.
Yeah, I like doing that. I like the way you did it. Figure out the number first and then figure out the plus or minus sign. What is the plus or minus sign?
It's a negative.
What about sine theta?
That's a negative as well. Everything that's not tangent is a negative.
Okay. So those are our 3 functions. Now all we have to do is remember what sine of theta, what's the and I'm going to give you a suggestion here. When you're trying to memorize these, do not have it on a piece of paper in front of you.
Okay.
Okay? Is all you will do is look at that piece of paper and read it. Doesn't help memorizing it. What helps memorizing it is to kind of treat it like a flashcard. In other words, see if you know what it is, and then look if you have to. But if you have it on a piece of paper in front of you, turn it over for a minute and see if you remember what the sine of 2 theta is.
Okay.
Do you? This is the easy.
2 sine theta, cosine theta.
Yeah, that's the easiest one by far to remember. So now let's just plug in what we have. What's the sine theta?
Negative 8 over 17.
The cosine theta?
Negative 15 over 17.
Multiply those 3 numbers and that's your answer.
So it'll be negative 16 over 17 times 2.
I don't see a whole lot of simplification, so that's just use your calculator and come up with a ratio. In other words, I can't cancel anything that I can think of. I guess I could cancel now. Even these 17s are not going to do anything with that 2. These are all prime numbers, so, well, the 8 isn't, but now,
the 16 over 34 times 15 over 17.
Right. In other words, you said 16 times 15 over 17 squared.
So 240 times, or over, okay, 240 over 289.
Okay. Now, as to whether we can simplify that or not, this is kind of hard to tell.
My teacher said that on the quiz she's going to try and make the numbers smaller to make it less of a pain.
There is a way you can tell here if that's simplified or not. It's useful to know whether numbers are divisible by 3, 4, or 9.
Okay.
A number is divisible by 9 if the sum of its digits add up to 9. Notice the denominator does.
Oh, okay.
So it's divisible by 9, but is the numerator, its digits add up to 6. Well,
Yeah.
a number is divisible by 3 if the digits add up to a number that is divisible by 3. So, if this is divisible by 9, it's definitely divisible by 3, and that's divisible by 3. So if I divide 3 into both, I get, why am I having trouble dividing that by 3? 9, What's wrong?
96.3333.
What the heck? That's not divisible by 3. It's only, how can something be divisible by 9 and not divisible by 3?
Yeah, that makes no sense.
Ah! When I added those digits up, I got 19.
Yes.
2 plus 8 plus 9 is 19. That's not divisible by 9, or 3,
No.
for that matter. So I used my wrong rule. That might actually be simplified.
Yeah, since 19 is prime. Yeah.
Yeah, I mean, I don't know of a better way to try to simplify that other than to break down each one of them into a tree and see if there's any common multiples. But
that's a really good trick.
yeah, but I'm going to say that's probably the right answer. Simplified even. Okay, so now let's figure out cosine of 2 theta. And we have 3 identities. One of them has both sine and cosine involved. One of them has only sine involved. One of them has only cosine involved. Which one?
So,
We could use any of the 3. We know all 3 functions. Seems we'd be better off using one that only uses one function.
okay, so we can do 2 cosine squared minus 1.
What's cosine squared of theta?
1 second, we can look at cosine again.
It's right up here.
The cosine is negative 15 over 17.
17, so that's 225. 17 squared is what? 289? I think it's 289, yeah.
Correct.
And minus 1.
So then 289, okay.
Okay, so that looks like it's minus 64 over 289 times 2. So minus 128 over 289. And I have a feeling 289 is probably prime. So I'm not going to find anything that divides into it. 9 doesn't, 3 doesn't, 7, nope. So I think that's probably your final answer. Yeah,
okay.
And the teacher would be wise to use smaller numbers because she doesn't want you spending all your time trying to figure out whether that reduces or not. That's arithmetic. That's not trig. You know what I'm saying?
Yes.
So, and using big numbers like this, it's not that easy to figure out whether it reduces or not. It's hard to factor these numbers in your head. And
True.
finally, tangent of 2 theta is equal to, do you remember the general?
I'm guessing I know 2 tangent theta, but I forgot the other one.
That's the numerator. Well, that's a good start. That's the way to memorize stuff. But the real way is to not have the answer in front of you. And each time try to remember it. And then if you're not sure, look at the answer.
Okay.
But eventually you'll discover that you have it memorized. But people that always have the sheet in front of them, or they always have the book open to those identities, they almost never memorize it because the brain is really lazy. It really is. If you can look at the piece of paper and read it, your brain isn't going to memorize it. I mean, maybe if you do it 100 times, it might. But if you really try to memorize it, you're better off not having it in front of you. Try to remember what it is, and then if you're not sure, look. Okay? Now, we figured out that the tan of theta was 8/15. So this becomes, the rest of it's kind of trivial. In other words, the rest of it's just algebra, arithmetic, whatever you want to call it.
Okay.
Okay? I mean, if you have any problem with past there, be sure to say something and we'll do it. But I don't think you do you?
No.
Okay. We're better off spending our time on setting it up and rather than the arithmetic.
Okay, so
What if they gave you a problem like, what's this equal to? Going in reverse. In other words, recognizing the identity first. What's that equal to? Sine of what? Notice that's the sine of 2 theta, where theta is 30 degrees.
yeah.
Remember, the sine of 2 theta is 2 sine theta cosine theta. So if I give you that part first, then it's relatively easy to go to there, and we know what the sine of 60 degrees is. It's root 3 over 2. So I can, rather than solving each one of those, and I mean I could do that times 1/2 times root 3 over 2 and come up with the answer, but they may just stick variables in there and not angles and make you do it. So it's useful to be able to go both directions on these identities.
Okay. So I have a different type of problem in this next one.
Okay, what is it?
Sine 2 theta equals cosine theta. Solve each equation on the interval of 0, 2 pi.
Okay. This is where, well, not yet, but when we have cosine of 2 theta in the equation, this is where it's very useful to have 3 different identities to choose from. In this problem, we only have sine of 2 theta. So what's the identity for that?
Say that one more time, please.
What's the identity for the sine of 2 theta?
I think it's sine squared.
No, that's cosine 2 theta.
2 sine times sine times cosine.
Like that, right.
Okay.
Okay, so now I have my equation like that. At this point, you want to treat it just like a quadratic you would treat. Get everything on one side, set the other side equal to 0, factor the left side, and so forth. Same thing you would do if you had an algebraic polynomial that was a quadratic. Okay, so I'm going to bring that cosine theta over to the left side, leaving 0 over there. Now factor out the left side. What do you get?
I can factor out the cosines.
What's left?
2 sine, cosine,
2
minus
sine
cosine.
theta minus 1.
Oh, since both the cosines got taken out.
Okay. Whenever you are factoring, particularly when you're factoring a greatest common factor like this,
Yeah.
the way I make sure I don't make mistakes is every time I write a term, I multiply it back by that to make sure I got that.
Okay.
Okay? When you initially said cosine, well, if you do a quick multiplication, you realize you don't get cosine. So that can't be cosine. What does it have to be? It has to be 1. Now 1 times cosine is cosine. So just a suggestion when you're factoring to help with accuracy. Now what can I say? Now that I have it as a product of two things equaling 0, that's the holy grail of algebra.
Would I look at the unit circle?
No, not yet. In other words, if I have a times b equals 0, what can I say? Either a is 0 or b is 0. You cannot multiply two numbers together and get 0 unless one of them is 0.
Would I take out the b?
What's that?
So would I make it or get rid of the b?
No, it means two things. Either cosine theta is equal to 0 or 2 sine theta minus 1.
1 equals 0. Okay.
Now let's solve all of the solutions for there. Where is cosine of theta equal to 0? In the unit circle. In other words, in the domain they gave us, which was 0 to 2 pi.
1 equals 0 on 270.
There's the curve of cosine of theta. Where's it equal to 0?
I know it's equal to 0 at 90 degrees and 270 degrees.
That's 3 pi over 2 and pi over 2. And the only reason I'm switching the radians is because when they give you the domain in radians, they most likely want the answer in radians, not degrees.
Okay.
Okay, and notice that the domain they gave us was 0 to 2 pi, not 0 to 360 degrees.
Okay.
So we're going to give them the answer in radians. Now let's solve the second equation. What's the sine of theta equal to?
That's equal to 0 at 0.
Hold on. Solve this equation first of all for sine of theta.
Would I divide it all by 2?
Well, first of all, you got to move the 1 over.
So plus 1 plus 1. Then divide everything by 2.
So sine of theta is equal to 1/2. Where does that occur?
That occurs at 30 degrees, which is pi over 6. 150 degrees, 5 pi over 6. And that's it.
So there's 4 solutions. That, and that. In other words, if you plug any of those 4 solutions into your starting equation, it will be true.
Okay.
Okay? And the way you solve trig equations is to, well, gosh, I guess this one that's not true, but generally you try to get everything in one trig equation. Okay, this one I can't do it because I have no way of converting sine of 2 theta to just cosine. If I could, I would. It would make the problem easier. It worked out okay here because I was able to get the product of one times the product of another, or one times another, and then I could solve it because each one of them sets to 0. But let me give you another example of what I'm kind of referring to here. If I had the cosine of 2 theta equals the sine of theta, now remember I've got 3 identities for that. If I can choose the one that is only sine, that one, now I have an equation that's actually a quadratic in sine. And I can solve it by factoring it just like I would factor any quadratic. In other words,
Okay.
I'm going to put everything on one side. I'm going to move everything to the right. So I got 2 sine squared theta plus sine theta minus 1 equals 0. Well, factor that just like you would factor 2x squared plus x minus 1 equals 0.
So I'll take out sine.
Well,
I'll factor out
instead of x, your sine theta is what is. This is called a quadratic in sine theta. This is called a quadratic in x. Okay? I can have other kinds of quadratics. I can have this quadratic. That is a quadratic in e to the x. The only thing you need for something to be a quadratic is if this term is the square of that. And notice e to the 2x is e to the x squared. Just sine squared theta is sine theta squared. So I could actually go through here and use substitution. In other words, I could say, well, let's let x equal sine theta. And now this thing will become 2x squared plus x minus 1 equals 0. That factors into 2x and x plus 1 minus 1. Okay, now resubstitute. Instead of x, I got sine, so it's really 2 sine theta minus 1 times sine theta plus 1 is my quadratic factored. Now, you don't need to do this step here. Once you get used to factoring these like they're quadratics, you can go straight from here to there.
Okay.
You just have to recognize that you're looking at a quadratic in sine theta. Okay, now what? In other words, we get down to this. Now what's the next step?
Can we cross out sines?
Yeah, I'm going to set that equal to 0, that equal to 0, and solve for theta. What if this said this? What if I've done all my factoring and I came down to this? Now, notice that one solution is the sine of theta equals 1/2, right? From this part. The other solution is the sine of theta equals minus 2. Are both of those possible?
Not the sine theta.
Right, not the second one. In other words, sometimes one of these two solutions will not be possible, and you throw it out. It's an extraneous solution. You used to have quadratics in x, that would produce extraneous solutions, or quadratics and logs that would produce extraneous solution. Trig's the same way. The rule says that if you multiply two things together and they're equal to 0, one of them has to be 0. It doesn't say both of them have to be 0.
Okay.
Okay? So you set each one equal to 0, and then if one is impossible, we throw it out as an extraneous or an impossible solution, and we're left with just that.
Fine. Okay, theta equals 1 over 2.
Well, and then you know theta is 30 degrees and whatever else the domain is. If it's within the unit circle, theta 30 and 150.
Okay.
Okay?
The next one I have that's confusing is sine 2 theta.
A sine squared theta. Oh, you meant sine 2 theta. Sorry.
Yeah.
My mistake.
Cosecant theta
I'm sorry, what?
times cosecant theta equals 1.
Okay. Unless I switch everything to the same trig function, I'm going to have troubles here. Let's first of all convert that. What's the identity?
For cosecant, wouldn't it be
No,
1
just
over
the sine. What's sine 2 theta?
or 1 over cosine?
Well, it's 1 over cosecant, but that's not going to be helpful. In other words, what the problem here is that's 2 theta and that's theta. Until we can get everything into theta, we can't solve this. So let's use the identity to convert that so that we only have theta. What's that identity?
2 times sine times cosine.
Now, what's cosecant of theta equal to?
1 over sine.
Now notice that everything is theta. And that cancels with that. So now we have cosine
theta equals 1.
1/2. In other words, I still have this 2 that I have to divide everything by.
Okay.
Okay, so what's theta equal?
And theta equals, so 1 over 2. And where cosine is 1/2, that is pi over 3.
And?
5 pi over 3.
Good.
Okay.
Okay. So when you see problems like this, your first order of business is to make everything theta. You can't operate if one is 2 theta and the other is theta. You can't do anything. In other words, if you were to tell me cosecant of theta divided by the cosecant of 2 theta, I can't do anything with that. Not until I get everything in theta.
Okay. Another weird one I have is cosine 2 theta plus 4 cosine theta.
Plus what?
Plus 4 cosine theta equals -3.
Okay, what are we going to do here?
We have to get rid of the 2 theta.
Okay, there's 3 different identities for that. Which one do we want to pick? The one that has what?
Squared minus 1.
Yeah, in other words, we want to narrow everything down to one trig function. I don't want to use cosine squared minus sine squared because then I'll have a sine squared. But if I use the 2 cosine squared theta minus 1, now
so I can cancel out the other cosine, right?
Well, now I have a quadratic. I have a quadratic in cosine, and as all I have to do is get everything on one side and factor it.
Okay.
So let's do that. 2 cosine squared theta, let's see, -1 plus 3 is +2, and there's a plus 4 cosine theta in there. So now I've got it in quadratic format, almost. What last thing can I do before I factor it?
Divide everything by 2.
Yeah, let's get rid of that. Now how does that factor? In other words, now I have cosine squared theta plus
theta 2 cosine theta equals 0. Or plus 1 equals 0.
cosine theta plus 1 times cosine theta plus 1. Is that what you said?
No, I didn't say that just now, but that works.
Okay. In other words, you need to factor that just like it was x squared plus 2x plus 1.
Okay.
Because whenever you have something equal to 0, if you have sums and differences, you can't solve it. If I tell you that a plus b equals 0, you can't make any progress on that problem.
Okay.
I can I can turn it into the product of two things. Now I can solve it. In other words, up here we had this plus that equals 0. I can't do anything with it. But by the time I get it down to here, I've got this times that equals 0. So what's cosine of theta equal?
Cosine of theta equals plus 1, or 1.
Minus 1.
Minus 1?
In other words, I'm setting that equal to 0.
Oh, so you have to subtract 1.
Right.
Okay.
And now what's theta equal to?
Then theta would...
Where is it equal to minus 1?
The only place it would equal to minus 1 is pi.
Good. And that's one of the few that there's only one solution in the unit circle. There's not two solutions. In other words, most of the problems, you're going to have two different quadrants, right?
Yes.
Almost always. But when it's 1, you only have one quadrant. When it's 1 or minus 1.
Okay.
For either sine or cosine, you always only have one answer.
Okay. Cosine 2 theta minus sine theta equals 0.
Now what identity am I going to use?
Oh yeah, the sine one, right?
Right. In other words, I'm trying to get everything into the same trig function. Well, I don't know how to convert that to cosine 2 theta, but I do know how to convert that to something that's all sine. So what is it? Do you remember? It's a it's subtraction.
I don't remember the sine one.
Notice the similarity. One says 2 cosine squared theta minus 1. The other is 1 minus 2 sine squared theta. Both of these are cosine 2 theta.
Okay.
Okay, I'm going to use this one because I got a sine theta here. Once I use that, I now have a quadratic. Take it from here. What do I do next?
I could cancel out sine, or factor out sine.
No. You can't really. You got this 1 over here. In other words, there is no greatest common factor.
What can I do with the 1?
Well, let's put it into a quadratic format. In other words, let's move everything to the right side so that we have positive signs here. Okay, so it becomes this.
Plus sine theta, and plus 1 equals.
I guess all I did was divide everything by minus 1 just then. Okay?
Okay.
Now, do you see it's a quadratic?
Yes.
Factor it.
Then I would just take out, oh yeah, it would be sine theta.
What goes here and here? Start there.
2 sine theta and sine theta.
Okay. Now, we know it's plus minus or minus plus, one or the other. Little bit of trial and error, you come up with that.
Okay.
And notice how you should check to make sure that's right. Okay.
I can fact.
Well, I don't need to check that term. I know that term's right.
True.
I don't need to check that term. I know that term's right. The only term I might be in doubt of is the middle term. Well, you get the middle term by multiplying the insides and the outside. In other words, the O and the I of FOIL only. That's the only thing you need to check. Well, that's minus sine theta. That's plus 2 sine theta. Add them together, you get plus sine theta. Is that our middle term? Yes, we did it correctly. Okay.
Okay.
Now, take the next step.
So then I would have to find where that equals that on the unit circle.
I'd like to see the next step be set that equal to 0 and solve, and then set that equal to 0 and solve.
So I would have to get rid of that too.
So start here.
Equals 0. Minus 1 equals 0.
Okay, so what's sine theta equal?
Then it would be plus 1 to divide everything by 2.
It's 1/2. Okay. What's theta equal to?
1.
No.
Wait. No. It would equal 1/2 at 5 pi over 6 and pi over 6.
Okay. So that's 2 solutions. But now we have this one over here that's going to give us more.
Yes.
Okay, so let's start that out right. Let's start out merely by writing this. Okay, now we finish it.
Then minus 1.
Where does that occur? And we know that only occurs at one place.
And that is 3 pi over 2.
All right. So there's your 3 solutions.
Okay. And the last one I have is cosine 2 theta equals cosine theta.
Okay. Which identity are we going to use for the 2 theta?
Can I just leave it at cosine?
Yeah, the one that's got just cosine theta in it.
Cosine squared minus 1. I mean 2 cosine minus 1.
There's always a 2 in front of the one that's being squared.
Okay.
Now what?
Wouldn't I want to get the cosine on the same side?
Okay, so what's the next line?
Minus cosine, so it would be 2 cosine squared theta minus 1 minus cosine theta.
Let's write it in proper quadratic format.
Okay.
Okay, because our next step is to factor this thing.
Correct.
So we want the constant at the end. So what's the
2 cosine minus 1 and then cosine plus 1.
Does that give you a proper middle term? That's the only one you have to check, is the middle term.
2 cosine squared, and then the outside is minus 1. I believe so.
No. This is minus cosine theta. This is plus 2 cosine theta. Add them together, you get plus cosine theta.
Explain the middle term thing. So I do the last and the first when I do that?
You do the O and the I of FOIL. The outside, 2 terms,
And
the inside. Add them together, that's what your middle term is made up from.
Okay, I'm going to write that down then. So that outside.
Now notice this gave us the right term but the wrong sign.
Okay.
We got plus cosine theta, so all we have to do is change the signs on these, and that should be right. Now notice the inside is plus cosine theta, The outside is minus 2 cosine theta. Add them together, you get minus, which is our middle term.
Okay.
Okay? So anytime you factor any kind of quadratic, whether it's in trig or algebra, you should
Check the middle term.
always check it by doing the inside and the outside
Okay.
to make sure you get the middle term, especially since a lot of factoring is trial and error. So you're constantly trying to find the numbers that produce the middle term. So a lot of times that process is not checking an answer, it's finding an answer. You have to figure out what those middle terms multiply to.
Okay.
Okay, now what's the next step?
Then it would be 2 cosine plus 1 equals 0. And minus 1, then would be negative 1 over 2. Cosine equals negative 1 over 2.
Theta equals
1. I mean, no. I was going ahead. It would equal 2 pi over 3 and 4 pi over 3.
that would put
Then
the third quadrant. Oh, and that's where it needs to be, second and third. Yeah, very good. Okay. And then the last part is cosine minus 1 equals 0, which means
I would make plus
equals 1. Where does that occur? Hold on.
Okay.
Dylan? Hi, I'm just finishing up. Can I text you the meeting ID number here in 2 minutes? Okay. I'll send it to you, and you whenever you get on, it's fine. Okay. Bye. All right. Taylor.
0 and 2 pi. 2 pi.
When you're given the domain 0 to 2 pi, it means theta is greater than or equal to 0, but less than 2 pi.
So it would just be 0 then?
Yeah, so 2 pi is never in the solution, but 0 is.
Okay.
You're right. 0 and 2 pi would both satisfy that equation.
And it's less than 2
But
pi.
2
Okay.
pi is not actually in the domain. So just 0. So there are 3 solutions, that one, and that one.
Okay.
All right.
Thank you for everything.
You're welcome. Have a good week. Talk to you next time. Let's see, that next time's tomorrow, I think, isn't it? Yeah.
Yes, yep.
Tomorrow at 5 your time.
Yep.
Talk to you then.
Okay, sounds good. Talk to you later. Have a good night.
You too. Bye-bye.